Welcome back to the InfoSec and Olsen Show, episode 53. This week, two random people contacted me about cracking passwords, so I thought I'd take a couple minutes and talk about hashcat today. First, let me give some background. As you know, BreachSense is essentially a large collection of breach credentials where we focus on providing security teams with as many plaintext passwords as possible. The main way we do that is by using hashcat to crack the hashes. Normally, when we get a data breach, the file contains a number of different fields like phone numbers, addresses, sometimes credit card information, and usernames, and of course passwords. The passwords, however, aren't in plain text. They're stored as a hash. And in simple terms, a hash is like a signature. So if we take a string of text and run it through an algorithm, it'll return a fixed length string, no matter how long the original text was. And for a given string, the hash will always be the same when you run it through the same hashing algorithm. So like imagine a one-way trapdoor. You can calculate the string of text into the hash, but you can't reverse it, meaning if you have the hash, you can't use that to figure out the original string of text. Now, this is different than encryption, where once you have the key, you're able to reverse the encryption and read the original text. Back in the day, all an app needed to authenticate a user was to hash the password sent when the user was logging in with the hash version of the password that was stored locally when the account was created, and all was good. Then came rainbow tables. And these were essentially pre-computed password hashes for common passwords that you can compare your hash against to figure out what the plaintext password was. So to combat this, we started adding a password salt. This is when we add some random bytes to the password before it's hashed. And this completely broke rainbow table hashes because the salted hash no longer matched any of the pre-computed hashes. But with modern computing power, it's pretty trivial now to generate billions of hashes per second, so adding a random salt to a password is really no longer that effective. And this is especially true when the salt is included in the data breach. So just to review, a big reason why we store passwords as hashes in the first case is just in case the database ever gets breached. Disclosing a user's password hashes, in theory, should slow down attackers from credential stuffing attacks against other services, meaning many folks reuse the same passwords across multiple apps. So if their Facebook password gets compromised, attackers will try the same password against other popular services like Gmail and Twitter. This is exactly how former President Trump's Twitter account got breached. Twice. So back to password cracking. In a recent podcast, Michael Bazell recommended downloading the cracked passwords from the former hashes.org website and using ripgrep to search the hashes to find a plain text password. My issue with that approach, though, is that you're severely limited into what strings you can dehash. Meaning, if the hash wasn't previously cracked by hashes.org, then you're kind of out of luck. So a better approach is to use hashcat. Hashcat bills itself as the world's fastest and most advanced password recovery tool. The software is open source as well as cross-platform, so you can run it natively on Linux, Mac, or Windows. What the tool does essentially is it takes a Word file and generates a hash for each line in the file. It then compares the generated hash against the hash that you're trying to crack. And if there's a match, then we know what the plaintext password is. So when running hashcat, you need to give it 4 arguments, but I'm going to focus on the 2 important ones. The first is the hash type. So before cracking your hashes, you need to understand what kind of hash you're dealing with. And there are different algorithms like MD5, SHA-1, or bcrypt. And if it's not immediately obvious based on the character makeup and length, you can use a tool like HashID to identify the hash type. There are also a bunch of websites that will do this for you. And for what it's worth, the current version of hashcat supports 332 different hash types, so it's pretty extensive. Now, the next argument is the attack type, and I suspect this is probably one of the most underutilized functions in hashcat. There are 4 main attack modes. First is called straight mode, which essentially just tries all the words in your word list. Second is the combinator attack, which essentially combines words from multiple word lists. So, for example, you have a list of words in one file and a list of words in the second file, and this mode then tries every possible combination of all the words in each file. Next is the brute force mode, and in this mode you define a character set and the password length, and hashcat tries every character combination in the defined range. Brute force attacks are definitely the most effective attack type, but not the most efficient, meaning given enough time, hashcat will try every possible permutation and will eventually get the right password. Though for any password longer than, say, 8 characters, it'll take too long and you're better off using a different attack method. Now, you can increase the efficiency of an attack by reducing the key space, and you do this by defining a mask. The idea behind this is that people aren't very good at generating random passwords. And very often when an app requires a capital letter and a number, people will just capitalize the first letter and append a number to the end. Oh, and when the apps require folks to periodically update those passwords, guess what? That 1 at the end becomes a 2, and then 6 months later, a 3. Masks let us significantly reduce the number of guesses by putting in placeholders in each position of the password that we're trying to brute force. So the placeholder will be either a list of custom characters, a built-in character list, or a static character. So for example, say we're trying to brute force the password ABC123. We can define a mask that says the first 3 placeholders should be alphabetic characters and the last 3 numeric. This way, we reduce the number of password combinations we need to try by exploiting common password patterns. For short patterns, this is probably the fastest way to crack hashes. Oh, and finally, there are hybrid attacks, which are essentially combinator attacks, where you combine the straight and the brute force attack modes, meaning you take a word list and then append or prepend placeholders onto it. And I should note that hashcat also has a rules language, so you can implement the same function as the hybrid attack using rules. And the rules language is extremely powerful. You can really maximize your word list by running various permutations on them. For example, you can change all the characters in the word list to be uppercase, or lowercase, or mixed case, or just capitalize the first letter, or the last letter. You can prepend or append the characters. You can do things like delete the first character, or the last character. You can delete certain characters, or repeat certain characters a certain number of times. Or you can rotate words. So, like say you're testing the word password, you can rotate it to the left, and it'll try password P. Another technique is character substitution. So, say you have the word table. You can spell it Table, or perhaps you can substitute the T for a 7 or plus sign, and the A is often changed to be an ampersand, and the B perhaps was swapped out to be a D, or the L is the pipe symbol or the number 1. There are lots of different common substitutions that would completely throw off a dictionary tag, but when we apply the rules language, it makes finding these type of passwords trivial. And I highly recommend you play with the default rule files that hashcat comes with to get an idea of how they work. Specifically, check out the best64 and the dive rules. These contain some very common permutations and should greatly increase the number of passwords you can crack. Finally, you need to have a good word list, and there are lots of lists out there. You may want to start off with like RockU or HashKiller, or even better, create your own, perhaps based on the hashes.org cracked passwords. Though no matter what word list you use, start developing rules that iterate on your word list to maximize their effectiveness. And finally, on the defensive side, once you play around with hashcat, it'll become very obvious that password requirements like requiring at least 1 capital letter, 1 lowercase, 1 number, 1 special character, and a minimum length of 8 characters doesn't mean much when your password is stored as a SHA-1 hash and the database is breached. Just an example, right before recording this, I took a look at a recent breach we imported that used SHA-1, and one of the passwords that caught my attention was 2011 Ford Escape ! With a capital F in Ford and a capital E in Escape and the exclamation mark at the end. According to most password policies, this is a pretty secure password. It's 15 characters long, mixed case, contains a number, contains a special character, but it was trivial to crack once the hash was disclosed. And when I say trivial, I mean it cracked in less than a minute. If the same password would have been in a bcrypt hash, or even better, Argon 2 ID, then this wouldn't have been feasible. And I won't go into too much detail because we covered that a couple weeks ago, but please check out the OS password storage cheat sheet for more information on how to store passwords safely. Also, make sure you use a password manager. You shouldn't know any of your passwords besides for the one you use to unlock the password safe. Let your password manager generate random passwords for you that are unique to each app that you use. There are many free and paid options available. Personally, I like KeePassXC. Alright, thanks for listening and coming back week after week. I really appreciate it. And I'll be back in your earbuds next Thursday afternoon.